This video demonstrates how an AI-driven system is developed using a toolchain that includes embedded Monty-Arc and Monty-Ana. At the first step, a neural network component is developed. Its architecture is defined in an ImageDL file using CNN-Arc language. The training configuration is defined in CNN train language and stored in a CNNT file. Next, the generated ImageDL to CPP is executed to produce target code. For that, we run a corresponding jar file and specify name of the model, its path, target folder, and the deep learning framework for which code is generated. After that, a neural network can be trained by executing the generated code in a selected deep learning framework. As a result of this step, the weights of a trained neural network are stored. Next, we can finalize the modeling by defining further embedded Monty-Arc components and middleware-related models like text for robot operating system. We then apply imam2 middleware generator to produce code for these components and a neural network component. The generator also produces middleware-specific code, for example, code to create a ROS package. Remember to include the weights of a trained neural network into the resulting application. Finally, the generated code is built and run. Here we demonstrate an application that implements direct perception approach proposed by deep driving. The application communicates with Torx, which is an open racing car simulator, by a robot operating system. The neural network part predicts human interpretable features like distances to further cars and road markings, whereas further components estimate driving commands like acceleration, brake and steering based on these features. This way, an application created with the demonstrated toolchain controls a host car and simulator. Thank you for your attention.